So hello, my name is Justyna Walkowska, and my presentation is called Should Everybody Learn to Code? It's quite obvious that this is going to be an opinion talk, but I'm going to base my opinions on experience and not just on imagination, so don't worry about this. I'm a programmer, but I have spent some time teaching. So I taught programming to university students. I taught programming to children. And I also taught, well, not programming, but computer science to seniors. The seniors have not become programmers. They have become spammers, though. So if your grandmother is sending you emails with a lot of PowerPoint presentations, this might be me. I'm very sorry about this. So this is one thing. The other thing is that I actually have had the opportunity to work with programmers who graduated from very different fields, like ethnolinguistics, for example, not computer science. And I also want to tell you a little bit about, what to expect from such people. There's one more thing that made me want to prepare this presentation, and here it is. So a dozen weeks ago, my computer broke. I was on a deadline. I was working from home. I went to get coffee, and then I came back, and the computer was down. My dog hasn't been electrocuted, so I figured, okay, it's not mechanical. Something happened with the computer itself. I tried to turn it on. There was no sound. There was no light. So I figured, okay, probably the power supply just burned down. I thought, okay, I might take it out. I might go to a shop, buy a new one, go home, and then realize it's not the power supply. So I decided to get help. I went to my husband, who's a programmer too, and I said, can you look at my computer? So he came, he had a look, and he said, this is probably your power supply unit. And I said, okay, but how sure are you about this? And he said, well, 90%. And then I decided to call for professional help. So I called a technician who came, and while he was doing his work, I had to just, look after him. So we did some chit-chat, and I said, okay, so are you still a student? Because he looked quite young. And he said, well, yes, I study at the University of Agriculture. So there was I, the programmer, and there was this guy from the University of Agriculture fixing my computer. And I said, I wanted to be honest with him, so I said, what, I'm a programmer. And he said, but don't worry about this. I fix programmers' computers all the time. So this just made me think, about who a programmer is today, because I guess that 20 years ago, a programmer would fix their own computers just in no time. So let's move back a little bit. Do you know what this is? Do you recognize it? Okay, so I don't want to show you this yet. Okay, so, sorry. This is the NASDAQ index. This is the index of lead technology shares. This is showing the year 2000. And as you probably know, in the year 2000, there was the dotcom bubble, and it burst. So, a lot of people lost money, lost jobs. And I started university in 2001. And I didn't know it then, but it was just, after this big crisis. So the situation was not as nice. The mood was not as nice as it is now. There was not that many jobs. And we had professors who were telling us, you know what, in 10 years you will not be necessary anyway. And, well, I spoiled it for you. But guess what they thought was the thing that would make all programmers unnecessary? This. Do you know it? This is the Boland C++ builder. This is one of the so-called RAD environments, Rapid Application Development Environments. So some people thought that with them, programming is just so simple that everybody will be able to do it, and we will not need that many programmers. Just like that. Okay, so here we are now, more than 10 years later. This is the full look at the NASDAQ index. So we know that the situation is much better, but when you look at this, it's kind of scary because we are approaching more or less the same point that we had just before the bubble burst. So maybe this is something to worry about. But if you are a programmer, then you know that the job market, at least here in Central Europe, is very good. So If you have a LinkedIn account or another type of online CV, then you get a lot of questions about, whether you want to try this job or that job. You can choose. You can work at a big company, some family-run businesses. You can work remotely. You can do R&D. You can do startups. So it's great. Actually, so many coders are necessary that more and more companies are willing to hire people who don't have a computer science degree. Just people who did, they did some stuff. They have something to show for it, and so they can be hired. And here I think that this is the moment in time when it's so easy to become a programmer. It has never been easier. I put some logos here. You probably recognize most of them. Some Coursera and edX are massive online course platforms. You can participate in lectures from the best universities in the world. They even check your homework. Kano and Eve are two Kickstarter projects. Kano, I think they gathered more than $1 million on Kickstarter, and they have already delivered the first batch of their products. And their product is this small computer, which is burnt on a Raspberry Pi and Ubuntu, and it's designed to teach programming to children. So this is a gamified, very social environment that teaches kids to code. Eve, on the other hand, this is also a Kickstarter project, but it hasn't shipped yet, and this is a software one. What they want to do, I think they are crazy, but this is interesting. What they want to do is they want to redefine programming yet again. They have this idea of a web platform, which is very much Excel-like, in which you can draw interfaces and connect them somehow, and this will be the way coding is done. You can also see the code that comes out of your moving things around. But they haven't delivered yet, so I don't know. I don't believe it. But this is very interesting, and they are supposed to show something at the beginning of 2015. Then there are things like Lego Mindstorms. Has any one of you tried Lego Mindstorms? Yes, so this is a nice, simple robotic kit. You have this programmable brick. You have some motors and sensors, and this is all compatible with Legos. And you can program it. There are two main ways of programming it. One is with some graphical blocks, but you can also just write code, either C-like or Java code to program it. The last thing I put here is the Rails Girls logo. And what I wanted to show here is that there's a lot of community effort to teach people programming, and especially to teach programming to the groups that traditionally have been left out. So this is a great thing. Okay, so let's say that your friend, who is a theater major, wants to learn to code. So how to do it, like how to start? I think that, in my opinion and in my experience, it's very good to see the results of what you are learning very quickly. And this is why I think that the first programming language shouldn't be a compiled one. Should be one that's interactive, interpreted very quickly. You can do something on the command line, for example, without even knowing that the mathematical operation you just used is in fact programming. Then we have to choose some kind of paradigm. What do you think would be best for beginners? Functional. Okay, sorry, this is my choice. But I'll tell you why. Procedural, of course, we have to go through it, but this is very disorganized. It doesn't teach them anything like planning, good practices, and so on. Functional, I know that functional is getting hot again, and it's good, but it's quite difficult. I mean, I know, professional programmers who are struggling to learn Haskell, for example. So I think it's too early for them. I put event-driven here as a joke, mostly, because some time ago with some of my friends, we did this Coursera course. It was called Interaction to Interactive Programming with Python. And it meant to teach beginners, but with event-driven programming. So they had absolutely no idea, why was this function called, what happened? And I even wrote to the teachers that I think this is a crazy idea, and they answered that I am biased, because, I was taught a different way, so I don't know. But I know that the beginners in this course, they were quite, shocked about this. And with object-oriented, we may argue that this is not the best way to do code, but it's a nice model. It's easy to say, okay, so an animal is a class and a dog is a subclass, and your washing machine at home is an object which has attributes and functions, and I get it. So this is why I think it's so good. When you are teaching somebody to code, it's good to learn many languages. It's good to, like a mature programmer will know when to use which language. This is why I think this conference is very nice. But when you are teaching somebody, you have to assume that they may just choose to learn this one language and stop. So I think it's good when this language gives them is quite universal. So they can do some, file operations on the command line. They can program some windows. If there is a web framework, it's even better. So does any language come to mind when I show you this? Nothing? Okay, so I choose Python. But I know that there are more languages. You can say Ruby is okay too. I think this is the best choice for the first programming language because of the reasons I just listed there. But I spent 5 years solving integrals at university, and they partied all the time. So will those new programmers come and take your job? Well, no, I don't think so. But you may discover that working with them is actually fun. So I've listed here, I will start showing them in a minute, the strengths and weaknesses of the programmers I worked with who are not computer science graduates. So like this. First of all, they are very enthusiastic because for them, it's a hobby also. When I go home after work, I don't want to do any programming, but they are so excited and they feel liberated with it. So they will spend their evenings learning new things. Often, if they found a new mentor, if they found a new course, they know the latest framework. So for example, I say, okay, I can do, C++, but actually the last time I did something big in C++ was at university. And they are quite probable to know the latest frameworks of what they are supposed to know. Then, say you work at some kind of software house and you have to do an accounting application. So you have to hire some domain expert. All the programmers have to become domain experts. In this way, when you have a programmer who actually studied something else, a different field, he is the domain expert already. So they are bringing some extra knowledge to the team. And this is a very good thing. And then, this is mean, but very often, there are some tasks that are boring and repetitive and you don't learn much and programmers don't want to do them. Well, this kind of programmers are often willing to do them. I mean, if something is too repetitive, then of course it's time to automate it. But anyway, they are just more willing to do this kind of simple stuff because they are just happy that they know how to do it. There are some problems. This is the biggest problem. This is the most serious thing I have encountered. So many of those people forget to test. So they have a task, they write a program, they run it once, and then they send it to the repository and they mark it in Jira, for example, as done. And then it turns out they didn't check border cases, they didn't write unit tests, they didn't even go to the continuous integration environment to check it. And this is something that just we have to teach them, to look for this kind of things. And of course, their understanding of mathematics is usually a little bit worse. This is not a big problem, I think, because the serious stuff you have to do as a programmer, usually the solution has been found by somebody else anyway. So, for example, people who do machine learning, they don't really understand, support vector machines that well. They just have to know that it's there, it can be used. But there's one small field where it matters, and this is, of course, in the computational complexity domain. So, again, you have to just force those people to pay attention, to know what they're doing. Okay, so this is the title of my talk. Should everybody learn to code? Well, I think yes, but not in the same way. Not everybody has to become a professional programmer. I have two different opinions here. The first one is by a professor from Georgia Tech, and he said, and I'm going to quote it, if someone is going to become a knowledge worker or take any job that requires an undergraduate degree, they should know how to read a piece of code that is useful to them and be able to make changes to it. I think it's very reasonable. Then the other opinion is from our idol, Linus Torvalds. And what he says is that no, everybody doesn't need to learn to code. This is not like reading and writing. This is more specialized. So no. But I stick to the first opinion. And this is why. Programming requires, but it doesn't only require it, it also enforces it and teaches it. So it requires logical thinking. Even more importantly, I think structured thinking, algorithmic thinking. I have a typo there. And also it makes you plan in advance. Because of this, I think programming, the basics of programming should be taught in primary school, just to like really, make people think properly, let's say. This thing has been pointed to me by one of the programmers who studied something else. He told me that when he goes and meets some friends from university, he's very frustrated with them when he sees how they take on like everyday tasks. So for example, they are trying to find a job, and this is a process, like you go to the advertisements in a paper, then you write a CV that matches them, you send the CVs, you wait for the response and so on. And he says that what his friends do is such a mess. It's like the pigeon algorithm, they go 2 steps in this direction, then 1 step in that direction, and then they are surprised that nothing comes out of it. So it really seems that when you learn to formulate a problem in this way that it can be coded, it's a skill that helps you in everyday life. There's also one, it's not minor, it's also important. When you understand how programs are written, how the whole domain of application development works, you are less prone to fall victim to some things. For example, like phishing. You get this email from your bank, there's a link, and they say you have to go and change your password, And if you have done some programming, if you understand a little bit how it works, you are less likely to just, believe it and give all the data to them. Okay, so when is it too late to change career paths? Because I said, okay, everybody should learn some coding, but what about people who want to do it professionally? So this is another quote. This is a quote by a Danish Nobel Prize winner, Jens Skau. So what he says is that in 1988 he retired. He started doing some research more for fun. And to do this research, he had to use a computer. So he discovered that it's amazing what you can do with a computer, how you can process the models and everything. And this guy was born in 1918. So can you quickly calculate how old was he when he started programming? Yeah, he was 70. So I guess it's never too late. But anyway, I prepared this kind of checklist, what to watch for when you are considering, dropping your current job and becoming a programmer. So the first thing and the most important is, have you tried it already? Is it fun for you? Or do you want to do it because it's supposed to bring money? Of course, if it's not fun, then don't do it. Are you ready to continue learning in your spare time? We know that, professional developers, most of them keep reading about new languages in their free time. They go to Coursera. So if you are a beginner, you should do it even more. Then, are you ready to work with people who are so much younger than you? Are you ready to learn from people who are younger than you? And are you ready to take orders from them? This is, I think, this is what's probably going to happen if you decide to change jobs at this stage. Then, what have you been doing recently? Because it really, I think it depends on the condition of your brain. So if somebody has been, stamping things at the post office for 30 years, they may not be used to this kind of work that programming, involves, of just thinking all the time, coming with solutions. Not necessarily. The brain can get lazy too. Are you okay with the salary that a junior developer will get? Because it takes time, to climb a bit. And then the last thing is, it's not a requirement, but it's great. Can you find a mentor? If you can find a mentor, a programmer, an experienced programmer who will just guide you in some directions, then, well, good for you. Okay, so this is what I wanted to tell you. Just to sum this up, It's easier than it was ever before to become a programmer. There are tons of learning options. There's huge market demand for programmers. And at this stage, people are so specialized that actually almost no programmer can do it all. So when you don't know something, well, probably other people don't know it too. I mean, nobody knows everything. The job market, as I said, is very good, but we cannot be sure if it's going to continue like this. The first thing was the NASDAQ curve I showed you, so we might have just another burst in front of us. Also, there's a lot of globalization and centralization of services now. If you have a good idea, your startup can make millions of money, millions of dollars, for example, with one idea. But then, when this kind of problem is solved once, it's often solved once for all, and a lot of people, including programmers, can lose their jobs because of that. Okay. There are some attempts to make programming easier, to make programming more available to everybody, and this also might include decreasing the numbers of programmers that are necessary. But as I showed you, people have been trying to do it for a long, long time and doesn't seem to work this way. And of course, we are getting more and more tech-oriented, so it seems that more people will need to work in IT anyway. Then, as I said, I strongly believe that programming should be taught in schools quite early, just to help people, think in a more organized, logical, structured way. And if I was to recommend the first language, maybe this is controversial, I don't know, but I would choose Python, or a language like Python, which is interpreted, which has some command line environment, which makes it possible for you to build some window application that you can see, and with a web framework too. So yeah, this is what I wanted to tell you. Thank you very much for listening to it. If you wanted to contact me, this is the address of my weblog. I will be moving from it because I outgrown it somehow, but anyway, you can still find me there. So thank you very much. Does anybody have questions?
Hello. All right. So my first question is
I don't know where to look.
I'm here, on your left.
Okay, I see you.
All right. So what is your opinion on tools like Scratch or Blockly? The tools from MIT, when you basically build your programs from blocks, you can, basically glue things together with loops and stuff like this. Okay, I was wondering, because in my experience, for example, when I tried it with my son, it's really a lot of fun for him, to build something like, dancing dinosaur or whatever. And I was wondering if the experience wouldn't be similar for people who are basically coming from, non-technical background.
Yes, I think those environments are great for learning, of course, not for coding like at work. The Mindstorms, the Lego stuff, I don't know if your son has tried it. It looks more or less the same way. You can draw loops, logical conditions, some actions of the motors and so on. And at first, when I looked at this a few years ago, I thought, okay, but you can only do simple stuff with this. And then I went to some competitions, for primary school pupils in programming these robots, and they can do a lot. So it's great. I really recommend trying this way. But I think it's the best when you can actually see the code later. I think it's a great step forward if after having, some fun with programming this way, you can, for example, start analyzing the actual lines of code that went through it. This is great.
And it actually allows you to do this.
Yeah, so yes, I think it's a beautiful beginning, yeah.
Don't you think maybe we should, the idea of programming, maybe it should be split in two different categories. One is actually, we may call, maybe there's another name, but maybe call it like scripting. Basically, so this is actually what most people will want. So they have some kind of data or something, and if they want to do a simple task that we want automate or something, and basically they just want maybe one-time code that they don't have to maintain, or they have to maintain like maybe 100 lines of code for themselves. And the other part is building complex systems, which what most professional programming are doing. And those two things are very, very different, and very, very different scopes and very different mindsets. And I would think that when we talk about the idea that everybody should learn to code, I think everybody should, if we accept that everybody should learn something, it's the first thing. But going from the first thing to the second one is, I've seen very, very few people actually manage to do it, because it's very, very different mindsets and very different motivations.
I agree with you, but only partially. I mean, because the division that you mentioned is practical. Like, they will need this kind of things and they will not need the other kind of thing. But I think they should spend some time, like 1 semester, I don't know, like writing applications, solving programming problems, because of the way it influences your thinking. They are not going to do it in real life, but there's a lesson to be learned there. So I think these are 2 different things. The practical solution that, okay, it's good if they know how to do it, and the idea of programming, which I think it's nice to know.
So you said that object-oriented programming might be easier to learn for beginners, but in my experience, it's often just because people that are used to do it and because they learned it first find it hard to learn functional programming later on. And so maybe if you're trying to teach the person that just begins their journey with programming, it might be good to start with functional programming because it's more similar to mathematics or other things they might know.
Yes, but this is the question, what level of mathematics do you expect from people? But I would like to see somebody trying to teach people starting with functional programming, not because I would hope for them to fail, but because I think it would be very interesting. But you might be right. This might be just the bias because we learn this way, of course.
So I wonder if you're aware of and can comment on the revolution in the computing curriculum in the UK that is just going into practice. It used to be that many children would learn how to use Word and Excel and this kind of thing. And I think from this year they're learning fundamental computing concepts, they're learning programming. It's really a huge change. Can you comment on that?
Oh, well, I think this is the right way. This is the right direction. I hope it's going to be the same way in Poland. Because, as I said, it's not only technical skills, it helps you in life. This is what I think. And also, sorry, it's a good thing because then women also do it. Because there's, there's still a lot of exclusion of girls who are taught, no, mathematics is for boys. And this way they can see quite early if they are good at this or not. I think this is another benefit from it. Okay?
I don't know if you are aware of, there's a TED talk about the current state of mathematics teaching. And basically this guy says that we're doing it wrong, and we're learning to do a lot of rote stuff, like computing integrals by hand and whatever, that isn't actually very helpful, because even if you go into mathematics, you generally never do it by hand. And he suggests, something which I think is quite interesting, that we should instead learn mathematics by programming. That is, like implementing algorithms to, I don't know, implement a division algorithm or integral solving. And I think this is kind of interesting from another perspective, because this might be another reason to learn coding. We learn a lot of mathematics in school that most people forget, and even those people who actually do use mathematics, they have to relearn it because it's generally not really kept in memory. And I think that maybe by doing this via programming, that would be a good compromise, that would allow you to learn the kind of algorithmic thinking that you mentioned is a good theoretical basis for everyday life stuff as well. And it also would, I think, improve the state of what people really understand mathematics to be, and yeah.
Yeah, it's very interesting. I'd like to see this talk, so I will probably come after you and ask you to show it to me.
I would have to look for it myself, so probably I don't have the link ready. But
this one, from my experience, when there's, for example, complicated algorithm, mathematical one, if I implement it myself, then I never forget. This is a good thing. But then again, you know, when you're talking about division in the first grade, I don't know if implementing it is the time, you know, they need to learn some mathematics before they learn some coding. But I'd like to see this talk, and maybe then I'll change my opinion. Thanks. It's the end. Okay. So we can continue over lunch if you're interested. Thank you very much.